Okay, so I'm done checking the attendance. Mr. Cuevas is not here, and as well as Mr. Munar. Ayan, nandito na pala si Mr. Munar. Ayan, kahabol pa siya. Let me check his attendance. Only Mr. Cuevas yung wala pa until now. All right, so okay, there are plenty of questions that has been sent to me, inquiries. For example, about the recording session last week. Unfortunately, we were not able to retrieve the recording because of the poor connection. I guess there was a problem with the recording as well. So wala tayong recording last session for that. But today we will definitely have the recording. I'm sorry for the technical difficulty. About the extension of the submission of the activities as well as the prelim case study or the prelim exam, I will be extending it. Do not worry to those who were not able to submit it yet. I'll still have to fix it later. And then there is a question because currently we only have the two machine learning methods, no? The linear regression and the logistic regression. All right. So, of course, you were not able to submit yet the other. I did not ask you to do the other machine learning methods kasi hindi pa naman natin na-discuss. Ngayon pa lang natin ma-discuss. So for today, we're going to discuss plenty of machine learning methods, 2 from the last topics that were not covered, and 3 topics for today. So more or less 5 machine learning methods yung gagawin natin today. And don't worry about that because the methods that we were not able to discuss are classification methods, and we can use those machine learning methods along with the other classification methods that we will be discussing today. Okay, and to begin with, who's gonna be the first reporter today? What we will do is that I will allow all the reporters to present their topics. And then after that, after all the reporters, I'm going to demonstrate the application and the implementation of the machine learning using one data set. I prepared a one data set, but I implemented around 6 or 7 machine learning algorithms for that. Okay, who's gonna be the first one? I think it's Mr. Cuevas, tama ba? Am I right, Mr. Cuevas? Okay, so I'm gonna give you the presenter so you can start with the presentation. Yeah, we can see we can also hear you. Are you still afraid to present it now? Relax lang tayo. Ang tandaan ninyo sa master's degree and even in the doctorate degree, if you still pursue, huwag kayo masyadong kakabahan kahit sa mga prof nyo, kahit mga doktor yung prof nyo. Huwag kayo masyadong kakabahan because the idea behind continuous studies to to learn all together. No, I'm learning from you, you're learning from me. This is the concept of continuous study or continuing study. Yeah, huwag kang mag-alala. We will be learning from you. Okay, go ahead, sir. Thank you, Mr. Cuevas. Ang taas namang accuracy no sa sa classification sa confusion matrix na pinakita mo. What are the other yeah. And what are the other machine learning algorithms that they have compared it with SBC or SBM? ANN, the artificial neural network. And then what? What else? Okay. Okay. Those are all for classification. Yung nag-stand out talaga yung support vector machine. Okay. Thank you. Sometimes the one machine learning model is very best for that particular data set. But you wouldn't say that SBM is really a good classification model to other data sets. So talagang may binabagayan depende sa data sets. And because of the complexity of the data sets at saka yung masyadong marami yung features ng data set na yun na nakita ko kanina, siguro it applies for SBM. So maybe when you try to study when you try to put it on a study, you can compare a lot of machine learning algorithms, and you see which perfectly fits on your data set. It all boils down to one thing, that every data set has its own characteristics, no? And one machine learning model applies to it while the other does not, something like that. Okay. Thank you so much, Mr. Cuevas. Our next reporter will be Miss Nipes, I believe. Am I right? All right, sige. Good afternoon po. Ayan, si Miss Sandra Lynn. I'm gonna make you the presenter now, so you can proceed. Yes, we can see it.
Sabi pala ako, parang pinapupukuhan ko.
Ilaw kayo rin, ilaw, ilaw. Ilaw, pakibukas ang ilaw. Thank you. Thank you so much for your comprehensive report, Ms. Nipes. Um, if your classmates have questions on your report, they can ask you right now. Otherwise, if there are no questions yet, maybe they are still thinking. But we will now proceed with the next report, and that is the report of sino ba yung ating next reporter, Mr. Ochoa. Am I right? Yeah, for KNN. Okay. So I will make you the presenter. You may now start. Yes, we can see. Mr. Ochoa, there are messages from your classmates because they can only see what page. Ayan, nag-move na yung page. Kasi kanina hindi siya nag-move. Okay, yan, kanina nung binanggit mo yan, hindi namin siya nakita. You are now on slide number 4, right? Sige. Okay, paki-check na lang. If you will continue, paki-check na lang kung nagmo-move yung slide. All right? Thank you. Yes, yes. It's okay now. All right. Thank you so much, Mr. Ochoa, for your KNN report. No? KNN, K News Network, K nearest neighbor, of course. So we'll be having some examples of that later. Don't worry, I'll be showing you some examples of KNN as well as SPM. We'll be having random forest and decision tree as well. And for the last topic that will be discussed, it will be discussed by um, Mr. or Miss Munilia. Ay, Miss pala. Sorry. Lagi ko na... so, di ko pa memorize yung mga ano nyo eh. Gender nyo. So, ayan. Okay, so I'm gonna make you the Gemma pala to. Okay. Make you the presenter. So you can proceed. While having the report, some are uh, typing some information on the public chat. They are very valuable information as well. Thank you for your contributions. Okay, willing to wait. Ayan. Na-base pala kayo. Yeah, it's okay now. You can go on.
Marami pa natin.
Excuse me, Gemma. Hindi rin yata nag-move yung... Ayan, nag-move na. Parang ano. Naglalag ba? Okay. It's okay. Kasi may mga nag-ask. Oh. It's okay. Pero syempre, nagtatanong yung mga classmates mo. Okay. Yeah, we are now in the tossing 2 points slide. All right. Excuse me, Gemma. We're still in the tossing 2 coins slide. You can also try to upload your presentation here in the plus sign. Just choose the manage your presentation and then you can upload your presentation. Once it's already uploaded, then there will be no delays. No? All you have to do is click the forward or backward directions or the arrows. The plus sign is in the left bottom of your screen. You can see it from there. You can click the upload and then you can select your file from your computer. Is it uploading now? If your file is too large, it will take time to upload. 90%. That's cool. That's good. Yeah, we can see it now. You can just click the next arrow. Yeah, the arrows. No need. Just proceed with the. I think you're done with the tossing 2 coins. Yan, lampas ka na dyan. Yeah. Yan, nag-introduction ka na dyan, di ba? Okay. Yan. Ayun, ganda pala ng presentation mo. Ngayon lang namin nakita. Sige, move forward pa. Move up. Yeah. What about after that? I think you're done with this. Yeah, you're done with this already. You explained this. Yeah, this one. Dito ka na. Is it a Google collab? There's no way to do that, no. It's only for ano. Okay. So there's no way to upload your files here in if it is a Google Colab notebook, you can share it. But if it is a Jupyter notebook only, the best way is to upload it first to the Google Colab, to your Google Colab, and then you can share the link later. Another one is you can upload it to your Google Drive, and then you can share it to us. Yeah, the link. Nice. All right. Thank you so much, Miss Munilia. for your report. If you have some questions with the reports of your classmates, now is the time to do that. Meron po ba tayong mga questions? Sorry? I can take the presenter. Yan. Okay. So it's okay if you can still see the PowerPoint presentation or PDF of Miss Molilia. It's because naka-upload na yung ano niya, PPT. Thank you, thank you. So right now, while we already discussed the theoretical parts and some sample applications of some learning algorithms that we have discussed. So we did discuss SBM from Mr. Cuevas, and then decision trees and random forest from Ms. Nipes. And we also discussed KNN by Mr. Chowa, and the last part was discussed, which is the naive base by Ms. Monilia. No? So I'll be showing some examples. For example, I can show you this example of random forest and the decision tree. So let me just look at it first. All right. I have some examples of random forests and decision trees. And these are the topics that were supposed to be discussed last week pa. But I also have another. I'll be sharing na lang the link of my notebooks para pwede niyo siyang i-download, or you can save it from your Google Drive. So the first one that I'll be showing is the decision tree. Ayan yung link po. I already shared it. Let me just show you the decision trees. This is the link for my decision trees as you can see from there. No? Of course, I need to connect first. And I need to mount the data because the data that I use for this is... no, there's no need for me to... because I use another toy dataset here from scikit-learn. Siya nga pala, yung scikit-learn, if you want to play with some datasets that are already available in the internet, I have this link for you. So these are from scikit-learn. As you can see from the site, it's datasets. We call it the toy datasets. It comprises small standard datasets that you do not require to download. No, all you have to do is to import it from sklearn or scikit-learn. We have the load Boston there, load iris, load diabetes, load digits, load linearad, load wine, and load breast cancer. So if you want to play with those data sets, if you want to discuss something to your class or to your friends, you can use these data sets to play with. Like for example here, in the discussion of the decision trees, as Ms. Nipes discussed, and also the random forest. So I'll be using this decision tree to basically classify the different species of this iris dataset. So the first thing that I did here is to import the load iris dataset from scikit-learn. And since decision tree yung gagamitin natin, I also imported the tree algorithm. And then I created the iris and used the function load iris to load the data. Afterwards, I separated the data and the target, and the data will be our X values, and the Y, which is our which will be the target, will be the iris that target. And as you can see, the codes are very simple. No? It's very straightforward. After you separated the data set, you can straightly use the decision tree classifier. And basically, if you want to do this, for example, here in the decision tree classifier, there are a lot of things that you need to understand here. No? If you want to check on the parameters that are used, there's a lot of parameters here, more of some typical default parameters. And if you want to learn about them, you can read it from this help tooltip. So basically, wala naman tayong ginamit yan. We all only use the decision tree classifier, and we use the blank parameters as if we are implementing the default parameters for our classifier. And then we fit the model. So if you try to run that, you can see that there's no need to load the data because the data was already imported from scikit-learn datasets. So now that we have trained the model, we can plot the tree with the plot function or plot tree function. So you can see here that this is an example of a plot tree function. Okay? So yung model natin na finite natin dun sa dataset na yon, we plotted it here. So you can see a lot of values. So you can see the Gini and Gini and samples. And these are the values that we can obtain from the nodes until the classification at the leaf nodes here. And we can also export the tree in a different format like graph.biz. And we can do that by using the export graph.biz exporter. Yan. So this is the way to do that. Basically, we can save the file into a PDF using the export graph.biz here. So all we have to do is to create an object and graph it. No? As you can see from here, we created the iris.pdf, very simple. And if you want to look at it, ito yung graph natin. So you can see, masyadong malaki. Kasi kanina, ang pangit tingnan dito, masyadong maliit. But we can actually save this. This is already saved. No? So you can save this into a PDF. So you can check it. No? So pwede nating paliitin yung ating data, yung ating screen para makita natin. Because it's too large to fit the screen. Yan. So this is a typical example of decision tree. Very simple lang, no? Yan, very simple lang siya. You can also create the what you call this? You can also export it in a textual format, no? Something like this. So as you can see, the final leaf nodes are classifications of two things, no? Yan. Based from petal width here, and petal width. So we have two classes that are mentioned here. And after seeing a classification example, we can also use decision trees as a regression. No? As reported a while ago, decision trees can also be used in regression examples. And right here, we can see that I basically created a data set here. So this is the data set. It comprises of this typical data set here. So we have some strings and some integers here. So this is the whole data set, as you can see. Oh, sorry, I did not import the packages. So there is no data set here that is needed. So you can just take a look at it. And afterwards, we can check we can represent some pictures in terms of X and Y. So this will be our X and our Y will be the target, which is in terms of these values here. And we can use it as the decision tree can be used as a regressor or for regression. So we'll have to import the decision tree regressor, and just for similarities, we can use the random state equal to 0. And we can fit the model, as simple as that, no? So makikita nyo yung sklearn has a lot of easy and very nice implementation of this machine learning models, no, compared to but you can also, as kanina may pinakita kanina na other methods of implementing the different algorithms. You can also implement that, no? But basically, some of the most commonly found in the internet samples are taken from sklearn. So let's try to run this. Ayan, finit na natin siya. And we can predict the value. For example, we predicted the value as 3,750. We can also change the values here if you want. So you can see that the predicted price is 8,000. So if you change the value, for example, you make it 4,000 here, given that input, so we'll still have 8,000 as the value. So the range is not changing. Right? So you can see here there is an example of how we can see the decision tree regression, because here this is an example of a profit to production cost. This is taken from this example. So here we have just use some values of random values, no? And we use it for the regressor that we have created. So we can plot it like this, and we can see that this is the output of the decision tree regression. We can also export it. No, same like in the classification or the classifier. We can do the exportation, and then we can also export it into a PDF, and then later we can show it, no? And as you can see, ito yung sample natin. You can see the prices here. So yung ano natin kanina, if the inputs, so nandito tayo kanina, no? Ito yung value 8,000, yung pinaka output natin. Based on the squared error and samples. So dito natin kinuha yung mga values na yun. So that's an example of decision trees. Next that I will show you is the random forest. But later I'm gonna show you an example na isa lang yung dataset na gamitin natin. So let me just show you this one. Random forest. I will also share this for you. Let me share it. This is my random forest notebook. Yan. So for the random forest, so I have a sample data set here. Hindi ko pa pala nasa-share sa inyo yung mga data ko sa Google Drive, no? Let me share it to you. Where is my Google Drive? Yan. So, share ko sa inyo to. Share. Get link. Copy link. So, if ever na I'll be showing you some notebook, no, may mga makikita kayong mga CSV files dyan na ano, ito yung content niyan. No? Makikita nyo dyan. Sa last na shinare ko is the dataset. Dataset folder. No? This is from my Google Drive. So, paki-copy nyo na lang yung link. So, you can access, you can download the datasets. No? Kesa maghanap pa kayo ng datasets sa internet. But you can also use the other ano. So I'll just connect the machine or the notebook. And automatically the drive is mounted, or am I going to mount it? So let's try to import the file. Yeah, it's automatically mounted, so I don't need to ano. As you can see, this is the link of my dataset. The name of the dataset is social network ads.csv. Yan, nakalagay siya sa aking collab notebooks. Mas may folder ako doon. Ito yung shinare ko sa inyo, yung data. And it contains a lot of data. No? Puro datasets yun. Mga sample datasets na gagamitin natin. And then from the dataset, if you're going to look at that, so since na-import na natin siya, let's take a look at the X. Ano ba yung mga X na yan? Anong laman yan? So these are the X, typical array, consisting 2 columns. And then our Y looks like this. Of course, yung Y natin, lagi namang 1 column lang yan. No? Yan. Makikita nyo 1 and 0 lang yung ating output. Alright? So, what you will be seeing at your X is we're taking at the column 2 and column 3, because there are column 1 and there is a column 1 that we will not be using for our entire data set. But if you take a look at the data set, ganito yung itsura niyan. No? So this is our data set. So we'll not be using this column 1. We'll only be using the age and the estimated salary. Kaya yung column 2 and 3 values yung gagamitin natin for the X. And for the Y, we'll be using the column 4. For purchase, it's either 0 or 1. So the concept of this data set is to show us na given the gender, given the age and the estimated salary, we're trying to classify whether they are purchasing or not. Yan. So makikita nyo yung 1 will be purchase and the 0 is did not purchase. Okay? So let's try to split the data set. Now that we have the X and Y, we can use the function from sklearn to train test split, so that we will have 4 types of data here. We have the X train, X test, Y train, and Y test. And we'll have 25% as our training. The test data set. No? So we'll have 75% training sets. Let's try to run that. And as you can see here, for the we are using random forest classifier here. So you can see that the first thing that we did here is to standardize the data set, no? Because you can see that comparing the age and the estimated salary, there is a big difference in terms of the numbers, no? So 19 lang to, umaabot ng 5 digits naman yung ating estimated salary. So pag pinlat mo yan, hindi magandang tingnan to pag pinlat natin to. Doon pa lang sa plotting, hindi na siya maganda tingnan. So what we did here is to do some feature scaling. So we standardize it. Okay, so ginamit natin yung standard scaler. Okay, and then after that, we fit the classifier into the training set. So from here, we use the random forest classifier, importing it from sklearn ensemble. Yan. So, yan, tapos ginamit natin yung mga values na to. So you can see that we'll be using the number of estimators as 200. So when we take a look at the random forest classifier here, and we take a look at the different parameters. For example, we take a look at the parang the same siya sa ano no sa decision tree, yung mga parameters. It's because as Miss Nipes said a while ago, the random forest is just para siyang combination ng decision trees. Actually, combination talaga siya ng decision trees. So we will be using it for our fitting, the X train and Y train. And let's try to run that. And for the prediction, we'll be using the X test. And this is the confusion matrix. Okay. So right now, okay. So asa na yung confusion matrix natin? Hindi siya nag-print? Hindi pala siya pinrint, no? So we can print the confusion matrix here. Okay, yan yung confusion matrix natin. So, to visualize the training set results, kasi meron tayong dalawang result dito. One is for the training set and the other one is for the test set. So this is to code the and visualize the training set. So since we're doing some classification, we can get the idea how much is the percentage of the ones and the zeros, no? So ito lang yung mga code na ginamit natin diyan. So makikita natin dito yung mga values. So run natin para mainit-init pa siya. As you can see, medyo nagtagal siya. Ayan. But taking a look at, this is for the training set, no? We also have a visualization on the test set. So ito naman yung sa test set result natin. And if you would like to compare that, you will see the difference, no? Okay, so basically, not so much of a difference, but basically we did some good things here on implementing the random forest classifier for this typical data set. So for regression, since we did the classification, we also can use regression for random forest. And this is an example. I have a wine quality red CSV here on my drive, which you can find on the link also. Ayan, nakita nyo na in the data set we have a lot of things to consider. So, ayan, hindi nagpapakita yung ibang data set. But if we try to describe it para mas makita natin at ma-appreciate natin yung mga columns, ito yung columns natin. No, binaligtad natin siya, no? Ito yung transpose na ginawa natin. Tinranspose natin siya kasi dito sa taas di natin makita yung mga column names. So dito, ito yung mga column names natin. It consists of fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur, total sulfur, density, pH level, sulfates, alcohol, and finally we have the quality, no, for the target. Okay? And these are just some basic data exploration. No? We would like to identify if there are missing values. So not so much of an. Okay? And these are some statistical tools that we can use. So for example, we can convert the absolute value of the statistical z-score, as you can see. And since maybe before, during the standard, the feature scaling, some of them are converted into negative values. So what we did is to get the absolute value, and then, yeah, we take a look at this. the z-score based outlier removal. Ayan. And then these are more on the statistical side, no? I'm not so much into the statistics. Well, ito yung isa sa mga weakness ko, yung sa statistics. That's why in my future studies I'm planning to dig more on the statistical side kasi yan talaga yung weakness ko. I'm having some troubles understanding about the statistics of many things, no, in the not only in the machine learning but as well as in the artificial intelligence or neural networks. But basically, yung ginawa natin dito is just nag-train test split din tayo. Now we use the quality as the target value. And aside from the quality, lahat ng hindi kasama, lahat ng aside from the quality, we use it as the features na gagamitin natin for the X values. So ito yung pinaka-importanting mairan natin dito. Oh, DFO is not defined. Okay, wait. So we need to, okay. So basically, ginamit natin itong DFO because we'll be using it as our data set. No? So yung Z conversion dito, where the threshold is equal to 3, yan, ginamit natin siya and sinave natin siya as our DFO. And then we separated, train test split tayo dito. Ayan, nakita natin. So ito na yung values natin. Nakikita natin siya. So our y-head. So yung y-head natin, it will be comprising of qualification from 1 to 5, I think. Okay? So tingnan natin yung y instead of y-head para makita natin yung itsura. So makikita natin, puro 5 and 6 lang pala siya. 5 and 6. As you can see, we use it, the random classifier first. Okay? But later, we'll be using it for our regression. So the first thing that we did here is to use the random classifier. So tinrain natin siya and we use the random classifier and we also use that for our prediction. And as you can see here, the accuracy score was obtained. We have around 69%. Pretty low, no? Mababa lang siya. And these are the columns for that we saw. And then, what else did we do here? Okay. These are the features, no? Feature importance, which are very, very important in getting the values, no? For each of them, ipa-plot kasi natin siya so that we can obtain the visualization, the feature importance score. Makikita natin dyan kung gaano ka-importante yung mga score natin. Bawat columns, in terms of columns. Now, meron tayong ginamit ditong random search, supposedly, and as well as cross-validation, pero hindi na natin ginawa. So, ginamit na lang natin is yung random forest regressor. Okay, so kanina, random forest classifier. This time, regressor yung ginamit natin. And as you can see here, these will be the output. And these are all the parameters that are currently in use, no? So ito yung mga parameters nung random forest regressor. So this time, ginamit na natin yung randomized search. So what we'll be doing is that we are looking for the best option, no? The best option. Parang ano to kaya lang medyo mabilis lang din to kasi we have a very small data. We're looking at the best or the optimal parameters, no, for this particular ano. And as you can see, if we try to run this, so these are the best parameters. No, these are the parameters that will be evaluated, no. Dito niya hahanapin sa random search na to, which is the best parameter. So gagamitin natin dito yung grid search and randomized search, and then we'll fit it into the model after finding the optimal parameter. So makikita nyo rito medyo matagal to. Siya nga pala matagal to. And then dito sa result niya i-display yung best parameter. And after that, evaluate natin siya using yung best parameter natin, evaluate natin siya using this performance evaluators, no? Like we will get the score and the error, and we'll use the MAPE, the mean absolute error, and then you can see that the accuracy of the regressor is 92.67. Hindi ko na siya hinintay matapos but I already ran this naman before. And yung best random naman is more on 93.54. So there is an improvement of around 9.93% using the base accuracy, subtracting it to the best random accuracy. And then we did cross-validation here. You can see that maganda tong note na to, no? Kasi itong notebook na to can be used to be applied in other algorithms as well, especially when you're trying to look at the best parameters, no? So makikita nyo. So finally, we have this value as our accuracy. All right. For my final notebook that I'll be using, no, I have this notebook. So let me share it to you. Where is it? It's called Crop Recommender. I came across on this in Kaggle. I forgot the I forgot the link. But I have the link of this notebook and I will be chatting it to you right now. So that's my notebook para ma-share ko sa inyo. And I'll be using one data set to perform decision tree, naive Bayes, support vector machine, random forest, logistic regression, and KNN. All right, and then we'll try to compare which one is the best, which one is better. So as you can see, I'm sorry that we are not able to record the last topic, no, yung linear regression at saka logistic regression. But today meron naman tayong logistic regression in our example here. So the data set is also in my Google Drive. This is the content, no? So as you can see from the data set, so I'm now connecting. From the data set, you can see that ayan, nagma-mount na siya sa Google Drive ko. We're trying to, this is a very good study, no, because this can be used in agriculture. And one of the groups of my advices in project design sa computer engineering undergrad, they opted to use this data set and they will be using it to create an application that maps the crop classification, no, dito sa Rizal. Okay, so yung label natin dito is the crop classification. So hindi lang rice yan. Hindi lang rice tsaka coffee po yan. Mamaya papakita ko sa inyo kung ano mga crops yung pwede nating itanim based on the following features. Like for example, nitrogen, potassium, phosphorus, and then the inputs on temperature is also considered, as well as humidity and then pH level and rainfall. Okay, so based on this data, so we'll be able to classify whether this yung project kasing gagawin ng mga undergrad advices ko, gagawa sila ng prototype, no, gagawa sila ng hardware talaga. Okay, so you may probe yun to check the NPK, no, the pH level, the humidity, and the temperature. I don't know how they are going to measure the rainfall, no? So it's up to them. Okay, so sabi ko sa kanila, alamin nyo kung paano nyo alamin yung sa rainfall. But basically, this is a very good data set. It contains around 2,200 rows. And ang sabi ko sa kanila, if you can search for other data sets that is better than this, so you can use it. And they are, in designing their prototype, they are considering to use 3 machine learning algorithm, and they would like to compare it kung sino yung best. Okay? So makikita natin dito kung sino yung best na algorithm. So this is the description of the data set. And as you can see, yan yung makikita natin description, yan yung shape niya. We have 8 columns, which consists of N, PK, temperature, humidity, pH, rainfall, and the label. Okay? So, hindi ko na niraran yan kasi hindi naman natin kailangan yan sa machine learning. So, for statistics lang yan and for data description. So, this is the heat map of the data set comparing the different features except of course the labels, no? And as you can see that the intersection, ito yung intersection na sinabi ni kanina. Now let's try to separate the features. Now the label will be our target, and the features, of course, except the label. So meron tayong 1, 2, 3, 4, 5, 6, 7 columns that we will be using for our features. So let's try to run that. And let's check on the labels. So ito yung mga labels natin. Price tsaka copy lang yung nakikita. Ito naman yung features natin na wala ng labels. And 20% yung test set natin na gagamitin. And let's see on the decision tree model kung anong score niya, yung accuracy niya mamaya. Okay? So, decision tree classifier, we'll be using entropy as our criterion, and the maximum depth natin is just 5. No? So, you can play around with it. No? You can adjust. And then, let's just see kung ano magiging result nito. And fit natin yung model using X-train and Y-train. And ito na yung ating mga predicted values. Dito nyo rin makikita pala yung mga different labels natin. Kaya lang hindi unique labels to, no? But ang makikita nyo na dito ay yung mga predicted values na natin, no? Coming from the test dataset na to. Yan yung X-test natin. So medyo konti lang yan, ha? Kasi 20% lang yan. Okay? So makikita nyo, ang daming combination ng crops. Merong orange, may grapes, may papaya, may yung iba nga hindi ko alam, no? May lentil, may chickpea, muskmelon, mango, coffee, pigeon peas. Yan. Kaya yan yung makikita natin. So let's try now to evaluate the decision tree model. So using the accuracy score, sklearn metrics yan. We'll be multiplying it by 100 para makita natin yung percentage niya. And you will see na 90% yung kanyang accuracy. Pataas na yan, no? 90% is a very high score. So let's try to print the classification report here for each crop. So makikita natin na yung average nila Ang importante dyan, yung average, no? 90% talaga siya, no? Sa lahat ng crop natin. Pero bawat crop, meron siyang classification. Okay? Using the y-test data and the predicted values, no? Yung nag-appear kanina doon sa atin. Ano? Okay? You can also save the model. As you can see, I saved the model in my Colab notebooks. But it's up to you if you want to save it somewhere else on your Google Drive, no, kapag niran nyo na to. Para meron kayong model and then you can implement the model later in your deployment. And later on, yun yung gagawin natin. Magde-deploy tayo ng model. Yan. So yan na yung ano natin, decision tree. Remember, 90% siya. Let's have naive Bayes. The next one. Sa naive Bayes, I think hindi nabanggit ni Miss Monilla kanina. Maraming klase ng naive Bayes. Meron tayong Gaussian, may Bernoulli, etc. etc. Maraming klase ng naive Bayes. Pero this time, ang gagamitin lang natin is the Gaussian naive Bayes classifier. Okay? So you can see na same lang naman yung yung mga codes, hindi naman nagbabago, madali lang siyang maintindihan. We also printed here the classification report. Okay? And wala tayong ginamit ditong ibang parameters. No? But you can use some parameters such as variable smoothing, yan, no? Number of features, kung medyo talagang nakafocus ka dito sa algo na to. So let's try to run it para makita natin yung kanyang accuracy. Oops, ang taas. 99%. No? Almost 100% na yan eh. So tingnan din natin yung kanyang per crop. So nakita nyo yung weighted average niya ng Recolo, tsaka yung F1 score, tsaka yung yung precision niya, 99%. So magandang model to, i-save natin, no? So fourth vector machine, no, yung report ni Mr. Cuevas kanina. So kanina, mapapansin nyo dito hindi SBM pero galing siya sa SBM, no? Na module. So SBC means SBC or support vector classifier. So yun yung parameter niya, yung gamma niya ay naka-automatic, no? Meron tayo, ang default kasi ng gamma is naka-scale, no? So dito, ang default niyang ginamit natin is naka-auto yung ating gamma. Marami pang ano diyan, no? Marami pang makikita kayo. For example, you can change the kernel size, you can change the degree, etc., etc. Looking at the deeper on the SBM. Tapos pwede natin siyang i-fit. Tapos let's test the as you can see, very low, no? Very low itong SBC na to kasi nasa 10% lang yung kanyang or 11% lang halos yung kanyang accuracy. Ito yung precision niya 60% pero yung ano ba to nasa gitna, recall at saka F1 score is very low sa 11 and 13% respectively. So hindi siya magandang model kaya hindi ko siya sinave. Let's try the logistic regression, no? Ito yung last week natin, no? So linear model, import logistic regression, random state natin, meron tayong nilagay diyan for similarity. And then finite natin siya and tingnan natin nasa 95% siya. Oh. Let's try to run it again, baka magbago. Oops, ganun pa rin, 95%. So, yung accuracy natin nasa 95%. Nasa 95% talaga yung weighted average niya. So, magandang model, pero not that good, no? 95%. Random forest. Ayan. So dito gumamit na tayo ng number of estimators, no, as part of the parameters dito. So yung default kasi niyan is 100, no? Tapos may criterion din diyan na pwede nating baguhin, may maximum features. na usually naka-automatic yan. So, automatic yan. So, pag ito'y niran natin, tingnan natin yung accuracy ni random forest. Ganda. 99% din, no? Yan, no? Tingnan nyo. 99% yung weighted average niya. So, sinave natin siya kasi maganda. Okay? So, magaganda lang sinasave natin. KNN. Okay? Kay Mr. Ochoa's report. Tingnan natin kung malakas. Gaano kalakas. Ang default natin dito, ang ginawa ko munang number 1 lang yung number of neighbors. No? Kasi dito, pwede nating i-tweak dito yung number of neighbors. No? Depende sa'yo yung kung paano mo makikita. But the default kasi, ayan, no? Yung number of neighbors sa default is 5. No? And ayan, may makikita kayo, may mga default dyan na metric. Yung Minkowski is the metric na default niya, no? Hindi yung dalawang klase kundi yung Minkowski. Algorithm niya is automatic. May leaf size siya na 30 and then may p siya na equal to 2. Yan. So yan yung ginamit natin. But basically, ang binago lang natin dito is yung number of neighbors kasi ang default niya is 5 pero nagsimula tayo sa 1. Okay, so let's try to check kung gaano kataas ang accuracy. Nakikita nyo rito, ang accuracy niya is nasa 97%. No, ganun din yung weighted average niya ng kanyang classification report, 97%. Alright? So, what we did here is to be able to test the other number of neighbors, no, kung may tataas pa yung value natin dito sa KNN. So maganda sa KNN, no, marami kang pwedeng i-tweak na parameters. For example, yung number of neighbors, I decided to find the optimal number of neighbors from the range of 1 to 40. So dito, tayo rito, nag-train tayo dito in a range of 1 to 40. And then, finigure out natin, ipa-plot natin kung ano yung best na depende sa error rate niya, no? So magbabase tayo sa error rate. So ibig sabihin yung pinakamababang error rate, yun ang pinakamagandang accuracy. Tama? Okay, sige, ayan, gumawa tayo ng function to do that. And then ito yung plotting. Oops, what happened? Okay. So let's try to import matplotlib .pyplot as PLT. And let's try to run it. Ayan, okay, ito yung plotting niya. Mapapansin nyo, ang pinakamababang error rate, no, kasi ito yung nasa y-axis natin is the error rate, on the x-axis is the number of neighbors, no? So mapapansin nyo, iba-iba, no? Hindi siya consistent eh. Pero mapapansin nyo, yung ginawa natin na 1, ito kasi yung 1, no? Yung pinakauna, yung number of neighbors natin na 1, ang kanyang error rate is nasa 0.030, malapit sa 0.030 o 0.029, something like that. But you can see that there are more better error rate, no? Like here, nasa bilangin natin 1, 2, 3, 4, 5, 6, 7. So 7, kaya ang ginawa ko dito, inulit ko yung command kanina o yung codes kanina, pinalitan ko lang yung 1 ng 7. Kasi ito yung pinakamagandang error rate. So nirun ko siya at makikita nyo na kanina, di ba, nasa 97% siya, di ba? Kahit pa paano nag-improve, no? Ayan, nakikita nyo rito, may improvement siya kasi nasa 98% na yung sa classification report niya. And if you try to compute on the accuracy, almost 98% na rin to. Okay? So to compare all the algorithms, I made this comparison of all the accuracy of comparison of all the accuracy of all the algorithms that we use. So gumamit tayo ng bar plot dito. So nakita nyo yung decision tree, Ang pinakamataas natin ay yung random forest, no? Na almost 99% yung kanyang accuracy. It's followed by KNN na merong nasa 98%. And then mataas din naman yung percentage ng logistic regression natin. No? Pero kulelat si SBM. So i-run natin siya uli kasi baka yung iba hindi natin naisama. Ayan, meron palang hindi naisama dun. So yung naive base, maganda rin. No? Mahabol si naive base. So considering the top 3, yung KNN, unang-una siyempre si random forest, no? Si KNN, tapos si naive base yung magagandang algorithm on this particular data set. Okay? So, ayan. So, dyan natatapos ang ating demonstration. So, if you have some question po, so lahat naman nakashare na sa inyo, you are free to okay. So, may question si Mr. Bragay. Sabi niya, is there a standard for the setting the accuracy on the evaluation of the model so that we can tell whether it is reliable or not? So usually sir, ang accuracy is measured in terms of 100%, no? Mas malapit sa 100% ang accuracy, mas better siya. So yun yung pinaka-basis kung kung mataas ang value niya. So sometimes when we calculate the accuracy, naka 0 to 1 siya. So kailangan i-calculate pa natin yan in terms of 100%. Okay po? In terms of ano naman, error rate, much better po yung mas pinaka mababang error rate. Kasi nga yun yung kabaligtaran ng accuracy. Any other question po? As usual po, bukas ko na rin bukas ko po ipapublish yung susunod ninyong assignment. Bukas ko po ipapublish yung susunod yung assignment. At bukas ko na rin bubuksan yung mga additional extension para do sa mga previous assignments natin. Question, sir, can we use these algorithms for time series kinds of data sets? Usually time series are I don't know if you can. I haven't used time series in machine learning algorithms, but definitely we can use time series for neural networks, particularly convolutional neural network, LSTM, etc., etc. How will we know if the data did not overfit given that the accuracy is 99%? So dito po natin based on the given example lang na ginawa natin, we were not able to determine the overfitting and underfitting, no? Sa totoo lang, hindi natin tiningnan yung underfitting at saka overfitting. And those two things are very dangerous. Now, saan tayo dapat mag-focus? Kung gusto nating malaman ang underfitting tsaka overfitting, we need to focus on one algorithm muna. Sa isa lang muna. Okay? So para malaman natin, of course, we need to study about that particular algorithm. Okay? Kung alam na natin lahat yung pasikot-sikot niya, including all the parameters, so malalaman na natin kung ano yung iti-tweak natin doon. Now, given malalaman naman natin yung underfitting at saka overfitting kapag pinlat natin siya in terms of the accuracy and the error rate, no? So malalaman mo kung sino yung nag-underfit at saka overfit. Okay? So let me have some example of that underfitting tsaka overfitting next meeting para mas ma-appreciate nyo yung answer natin dyan. Magandang question yan, sir, no? Itong tanong ni Mr. Peña. Other questions po? Sir, remind mo ako, Mr. Peña, magpapakita ko ng example ng underfitting tsaka overfitting para mas maintindihan natin. Okay, other questions po aside from Ayan, nag-change na into dark mode yung aking window. Ibig sabihin, gabi na. Magandang gabi na sa ating lahat. Other questions po before we end our discussion. So again, I mentioned na bukas ko po i-send lahat yung assignments nyo kung uploaded na siya, and as well as the extension. So don't worry yung mga busy lagi sa work. Extend po natin yung mga assignments. Okay? So don't worry po. I know naman na you're busy, so don't worry. Madaling kausap si Sir Tyler. So patayin ko na yung recording ha. Kung wala na tayong question. And then I think if it is okay na, wala